Griff, thanks for inviting me up onto the roof on this lovely August summer day. The rain's just coming in.
The sun always shines in Yorkshire Dales, so here we are.
Obviously, ironic, we're on the roof with a solar installation. How old's this installation?
This installation now is about 12 years old, so halfway through a typical lifetime of an install.
And what sort of power, how many panels have we got on this roof here?
So we've got a total of 112, but would you believe, even looking back at the modules behind us, these are only 235 watt modules. So it's about 27 kilowatts. And at the moment, that's across 2 inverters downstairs.
Okay, so that's, in its day, was quite a big installation.
Oh, it was huge in its day, yeah. I mean, 235 watt in a module was
state-of-the-art.
State-of-the-art stuff then, yeah.
And obviously the installation doesn't look too bad. We've got a few leaves that the guys are cleaning up in the background.
I have seen out of the corner of my eye, there's an electrician with a brush, and they're actually using it, which I don't think I've seen before on a site anywhere. But
take note, Rick. So we're up here today. The installation's having a bit of a, sort of say, a midlife refresh.
That's right. Yep. Nothing like updating the system to keep it on top form. So when the inverters were installed, your typical lifespan of an inverter would have been 10 to 12 years. So we're really pushing that out now at 12 years plus. They're also installed in a plant room, so it's quite warm in there in any case. So we decided to upgrade the inverters, but of course it's a bit like pulling at a jumper, a little bit of wool on the jumper. Well, perhaps we should have some batteries. Well, if we're going to do that, let's put it all together then and come up with a system that's got some optimizers on it as well, because one of the things I'm really interested to see is how the modules are actually performing now they've been in for 12 years.
Now, obviously, when people think about optimizers, normally we're thinking you put them in because of shading.
Yeah.
And I can see lots of trees in the area, but
we're on top of the trees, right?
You're on top of the trees for now. That one there, I think, get another 10 years, you might start having a problem.
So yeah, this for us is very much about looking at what the modules are actually doing, as opposed to trying to overcome any shading issues. The whole roof space itself is actually facing east that way. So we get loads of sunshine in the morning onto this side of the system. And then as the sun comes over towards the west, we get a little bit of shading from those at the back, but really at that point, it's not massive amount because it's heading west anyway. We're looking to really identify the modules and see how they're performing compared to what their production spec was 12 years ago.
All right, and can you get an estimation of where they are from the current inverter?
No, because they're just all single string inverters. So we get an idea of what the total output is, but not of individual modules. And for me, being a bit geeky, that's a really important thing I want to see.
Yeah, but it's still producing reasonable amounts of power today. So
it is. Yeah, we've got no reason to think that anything's wrong. We've had a couple of instances of an insulation resistance fault coming up when we've been doing the inspection and testing. That's been a big cost to us. It's one of the reasons why we've decided to do this as well, because you need to scaffold the entire roof just to come up and start to do work to fault find that. So this is, as you say, a whole sort of refresh halfway through a lifespan just to try and get on top of all that future maintenance.
Yeah, now it looks like at the minute the guys are taking a lot of the panels off. I thought I was just going to come up here today, you'd be quickly flipping the panels up, hooking those optimizers on and putting them back down again. Why they're sort of
That'd be
stripping them
lovely.
back.
We've got to strip a load off so we can get safe access around the roof. So the roof itself has got a load of skylights in it as well. We've got to be really careful of those skylights because they're quite brittle now, having been exposed to the sun for so long. And also just to get on and off the roof and to walk around on it safely, we had to take a load of modules off so we can then retrofit the optimizers to the roof and then put the modules back down.
Okay, and you're also changing the string configuration?
Yeah, that's right. So the older ones, the older inverters, the way that was set up was 6 strings, so 3 strings per inverter. We've mapped it out using the SolarEdge design tool. And because they're actually such low power modules, on the SolarEdge platform, we can get that down to 4 strings, but still with the same output capacity.
Okay, so that's, you only need 2 inverters with 2 strings on each inverter. Yeah, which, you'd be interested to see where that insulation resistance fault was, what caused it, because obviously we don't see a lot of people going back to old installations like this.
No, so I've been back to quite a few where they've had insulation resistance faults, and it is almost always either at the start of the string connecting to the modules or the end of the string connecting to the modules where somebody's made a connection off on the roof and or it's been an incompatible connector and the watertight seal hasn't quite been made off, or the joint hasn't been quite made off properly, and you get water ingress, and that causes an insulation resistance fault.
Okay, it was a problem 12 years ago. It's still a problem today.
It's still a really hot topic, those incompatible MC4 connectors today. Yeah,
and we'll be coming back to that. I've got a new shiny toolkit to show those connectors.
Bring it with you today?
I didn't bring it with us today. I didn't think we were reaching to this level. Now, there is a saying up here, you can tell when it's about to rain because you can see the hill. The hill's just starting to vanish, so you just get off the roof and have a look at the inverter.
Excellent, let's do that.
This change in the weather gave Rick the opportunity to go hunting for lunch, and he found the nearby Wensleydale Creamery and plenty of free samples, of which the oak smoked cheddar is now his particular favourite. Hunting round a gift shop looking for gifts for the kids? Well, I'm sorry kids, yet again, Dad's coming back with a bag full of cheese and not that Wallace and Gromit cuddly toy that you first wanted. So Griff, we're in the engine room, so to say. Now this rig doesn't look like a traditional solar installation. We're not used to seeing inverters with wheels on.
No, not usually, but here we like to have everything so we can move it round and make sure the candidates who come here get the best experience and can see every aspect of the installation that we've got actually driving the building.
Okay, now obviously, yeah, that's quite rare actually for training centres to actually have solar panels on their own roof when you train people, but you're using these as part of your training that you do here at GTEC.
Absolutely. So not only have we got the sort of 26, 28 kilowatts on the roof that benefit us in the office, we also use that same rig to do some of the training and inspection and testing on during the courses. It's a real life scenario. We've trained these engineers to be competent. There's no reason why they shouldn't be doing it.
All right, so how many people do you think have had their hands on these rigs?
In 12 years, it must be thousands.
Wow.
Yeah.
And that seems to be shaping up pretty well. I mean, okay, you're saying 12 years, that they've got a whiff more of 1980 in the design design of the unit. You wouldn't. It's got a hint of probably someone who used to work for IBM. You could see a keyboard
absolutely.
On the front
a few flying ducks across the front here, and you'd be right at home in the 80s. Wouldn't you?
That's it. But they're 12 years old, still working.
Still working. We've had to do some repair on some of the MC4 inputs here. We had a set that started to fail. So we repaired that. That must have been a repair maybe 5 or 6 years ago. Okay. Apart from that, they've not given us any trouble, but it's 10 to 12 years life expectancy of an inverter. We wanted to add battery storage, so it seemed sensible to do everything at the same time.
Yeah, and obviously those connectors probably gone because there's been a lot of people plugging them.
Absolutely.
And plugging them back in and out and in and out.
It was a mechanical failure, not an electrical, not a fire, not an overheat. It was just a mechanical failure.
Right, well, that's interesting. So one thing I don't see on this board, and you caused outrage the last time we had you on a live stream, there doesn't seem to be any DC isolators.
Well, doesn't seem to be, but there are actually some underneath and built into this particular inverter. And you can hear that there switching on and off, and that will actually isolate all of the strings that come into here. So we've got 1, 2, 3, 4, 5, 6 strings that are all isolated by that there, which is a stacked column of switches inside the unit itself.
Okay, and that seems to be the guidance people are going in, is to try and reduce the amount of DC isolators in a system. Absolutely,
and now, especially as there's been a new document published this year, which is a joint document between SolarEdge UK, MCS themselves, and the Fire Protection Association, who've actually, the authors and the publishers of the document, have said to eliminate the use of DC isolators wherever possible, recognising that the ones mounted within the inverters are perfectly acceptable to form that isolation point.
Yeah, as long as they've got that proper IEC standard on the isolator, which I took the back off one of the ones that we've got a SunSync converter back at base, and it is indeed stamped on the back that it's classed as a proper isolator, and that's all you need.
That's all you need. It's a means of isolation. Obviously here we've started work on the roof already, but we'd have been switching it off like that, and then we can safely disconnect all of these connections here to then work on the system.
Okay, then other kit, we've obviously got the mains isolator, that still stays?
That still stays,
that's not going anywhere.
Yeah.
We've got metering?
We have, so this is actually an MID certified meter, so we're fortunate enough on this system that we've got the feed-in tariff going back about 12 years, so it's about £1 million a kilowatt hour now. It's Yorkshire, we make the most of it.
That's it.
But the meter here we changed out a little while ago to be a KNX based meter, so this is all about the smart metering side of things, and this allows us then to have these meter readings emailed to us rather than having to actually come down and read them.
Take those manual readings. Yeah.
Yeah.
That's it. Yeah. Did you have to go through a process to say you were changing the meter?
We did.
You have to fess up.
So we had to take a photograph of the original meter and then take a photograph of the new meter, but actually it was much, much easier than I was expecting it to be. And they passed it through without any problems.
Right, you're still getting those payments.
Still getting those payments.
A true multifunction system we've got here. You're using it for training, using it for your own energy, and you're getting paid for it as well.
And this week, because we're expecting to have a week of downtime to get everything right, it's a week in the middle of August. There should be lots of daylight hours. I am starting to have a few palpitations about that. Yeah. But the investment or the loss of revenue will be worth it in the long term.
Yeah, well, you've scheduled some rain in for today.
That's
so
right.
The guys are delighted to be on the roof. You can thought you'd planned that. So the new installation going in, we've got some SolarEdge inverters and their battery setup. That's
right, yeah. So we've got two 10 kilowatt SolarEdge inverters. It's designed to be oversized. Oversized on the string size. So there's about 13 kilowatts going into each one of those inverters, and they're really tolerant to oversizing. That means that we can drive a little bit more into the batteries when we need it, but it also keeps it below that 3.68 kilowatts per phase, because we've actually got two entirely separate systems running here.
Right, so you're on G98 on this?
That's right.
Yeah, okay.
Yeah.
That's, you've done
to date.
Two separate systems, right. That's it. Yeah, so these inverters, do the inverters have to talk to each other as well?
Not these, yes, these ones are talking to each other through a little comms unit that's on the back there. That's just to make sure that the voltage that this inverter is outputting isn't competing with the voltage that this one's outputting. So all the inverters work on the basis that this one will take a look at what the mains voltage is. Let's say it's 235 volts, and it says, well, to push it back down and back up that cable, I need to be 237 volts. If this then starts to see 237 volts, it goes, hang on a minute, I need to be 239 volts. And then sometimes you can end up with a bit of a fight between them. So in a typical multi-stacked inverter environment, you would have one lead inverter or one master, and then a series of slaves operating off the same voltage measurement of the incoming voltage.
Yeah, so obviously the SolarEdge system talks to everything, including the optimizers on the roof. It does that through the DC cables? It
does, yes. It's really clever. There's no separate wiring required to talk to each one of those optimizers up on the roof. It'll just do it through a standard pair of DC cables. So one of these strings, when we get reconfigured on the rooftop, that will plug into the bottom of the SolarEdge inverter, and it'll start to recognize and pick up those strings.
Yeah, and that's the intelligence of their whole system. What other things do you think we might find out from the panels? Obviously, once you can get data from each and every panel, is that going to show up I spotted when I was up there some bird poo.
Oh, no, we don't have birds pooing on our modules up here. We're far too posh for that, sir.
Yeah, would that would a large piece of bird poo, for instance, cause a problem with a panel? Yeah,
especially in a as you've seen from being up there, they're older modules. The way that they're configured, and they're actually a polycrystalline module, that's going to lead to a better chance for a smaller bit of debris to give an imbalance on that particular module. So hopefully we'll be able to start to spot those and take a look. We'll probably only need it running for about a week, and we can get some accurate analysis on whether there's one that's performing really badly that maybe we replace now while we've got the scaffolding up.
All right, that's it. Or could you just, well, I guess the optimizer would take it out of circuit if it was really poorly performing.
It might do, just depending on what the fault was itself.
Right.
But generally it would flag up as an error, and it would be for you to decide what you wanted to do with that.
Yeah, and that's going to be interesting for us. I mean, I guess we've got to let the guys crack on, finish the install. It has stopped raining again. It's still not sunny, and we'll come back in a few weeks to find out how these modules are performing.
Excellent. Thank you very much.